Okay, Assalamualaikum and good evening. So we will start now. Sorry, the line is quite slow. Dia tak boleh buka kamera tu. Right. So we will continue with topic on water treatment. Okay. So boleh kita mulakan sekarang? Okay, Fatin. Okay, boleh? Fatin dengar my voice? Dengar tak? Fatin Amirah. Mina dengar tak saya?
Dengar, Madam.
Dengar Okay, saya proceed. Yeah, our topic today is on water treatment. So we will do an exercise. So I just brief on the theory sekejap. Tu kita terus buat kepada latihan. So 5 to 6 is very tiring. Kita terus kepada latihan sekejap. Okay. So on topic on water treatment, I will repeat again that here we will look into all the calculation and also what's the issues related to water treatment. Okay, kita akan nanti kita akan masa 2 jam nanti kita akan back to this slide. Okay, so what we're going to see today, so on the treatment, right? Okay, on the treatment, sekejap. So treatment, so this is surface water treatment plant. Is for the treatment for drinking water. Right? So by looking at this process, kita nampak proses dia adalah it come from the sources of water from the water intake. Then we have a screen, to screen all the rubbish, to remove all the rags, all those kita kata on the big size of the rubbish, kita akan keluarkan masa proses screen, and then all here is the process. So normally kita akan cuba sketch dan memorize lah the process, right? Sekejap ada yang nak masuk sekejap. So here you can see the process is start with a rapid basin, then followed by rapid basin, followed by Foculation basin, sedimentation basin, then we have a sludge here. Okay, I explain what is sludge. Rapid sand filter, disinfection, storage, and sometimes we have the plant at the pump due to elevate the water up to the distribution line to distribution system. So here why we have this as a sludge, sebab during water treatment itu akan ada suspended materials. Suspended material ni akan dikeluarkan masa dalam proses of treatment, dipisahkan dengan air. So what will happen, it will settle down at the bottom of this basin. It will settle down at the bottom of the basin, and so dia akan dikenali sebagai sludge. So we will remove the sludge. We need to know how to manage and handle the sludge, because normally we produce a mass of sludge. Banyak So sludge ni macam lumpur, masa dia keluar tu dia macam lumpur. Lumpur tu kita tahulah yang tanah yang basah dan berat dan sebagainya, itu perlu yang kita manage as engineer. So this is what we call a treatment that we name it as a conventional surface water treatment plant. It's a filtration plant. Sebab ada process of rapid sand filter di situ. So that's why it called as a conventional surface water treatment plant, in bracket is filtration plant. So we will start on the calculation on the rapid mix and also to look at the Foculation basin, because these both they ada kaitan. So this is what we're going to see. So what is rapid mix? Ini I can explain back again sebab this is only 1 hour. So the process is to remove for the whole process of this treatment system adalah remove suspended materials, turbidity and color, all the suspended materials that give us the color. And number 2 is to make sure that the water is safe to drink, whereby we will eliminate the pathogenic organism so that it was safe to consume. So these two, right, is the main purpose of the process, so that we the process have to be sure that the water is clean and colorless and safe to drink and to use. So the technology that we use is what we call a coagulation and foculation process. So this is the treatment technologies that we use in this process. So what is coagulation? Okay, very fast. So I will just explain what is coagulation. Coagulation adalah proses di mana ia um, turn the small particles yang di dalam air, particles yang menyebabkan color, turbidity dan bacteria itself, because bacteria tu dia ada size, so kita kata small particles ini into a larger flux. So we need a process to remove of those particles. Macam mana kita nak buat? Small particles ni kita akan jadikan dia sebagai bigger flux. Kita jadikan dia sebagai much more heavier, so ianya lebih mudah untuk settle down. So it will be, dia akan timbul as a what we call precipitate, dia akan nampak as precipitate, and also suspended particles, and it will remove in the sedimentation basin, it will settle down. So yang tu yang kita panggil selepas itu adalah sludge. Dan for coagulation process, kita akan pakai konsep ini di mana the colloidal sebelum dia bergabung menjadi flock, so we call it as a colloidal particles because they have very strong the iron around them, and then they are very stable, so they stand on their own. Tapi bila kita introduce the chemical like alum, di mana dia mempunyai positive ion, and then it will start to collide, then dia akan form a bigger flux. So that is the purpose of coagulation. So what's the chemical that we use? We call trivalent cation sebab dia ada 3 kaki, 3 positive, and when we mix with the water, it will separate the H2O and also the precipitate, the suspended materials. So dia akan pisahkan the suspended materials and also with H2O. So that's why we choose the chemical that is safe to use, like alum and ferric ion, to be used in process coagulation. Okay. Right. Then so here we have example 6.1. I will share with you in the WhatsApp, the exercise. The next process adalah mixing and foculation. So we have a rapid mix. In order that we mix the chemicals with water, we need a process that we call rapid mix. Tadi nampak dalam proses the flow of the treatment adalah rapid mix, and then followed by foculation. So foculation adalah proses, masih lagi stirring technique, but more slower and also gentle in term of mixing. So dalam proses itu kita akan ada pada mulanya kita akan ada very high in term of mixing process, we call a rapid mix, and then followed by foculation process yang kita namakan sebagai slow and gentle mixing. Okay, get these two first. Then of course bila kita nak menggunakan technique of mixing, we need to have the power of input. So the velocity gradient, the movement of the water, and also the steering effect. So we use this formula G is equals to P divided by mu times volume, kita ada to the power of. Then you can see that of course the power yang kita nampak tu, the power input tu, maksudnya dia ada keperluan lah di situ. Okay, so here we'll now to ensure that we have a stable and consistent technique of mixing. Then pada sini kita ada beberapa rapid mixing, the type of the rapid mixing. Right, so just forget about the quiz kejap. So this is how it looks like. Sometimes we have a very big tank. So we have the tank. So where we have a pedal, dan dia akan mengacau. So dalam rapid mix ni is a higher rate of the mixing. That's why kita pakai rapid mix. So we have a chemical addition into the water. Then this pedal will move so that the water will mix accordingly with the chemical. So this is the process of coagulation. Yeah. Rapid mix dan dalam proses coagulation. Coagulation adalah proses chemical yang dimasukkan. So rapid mix is the mixing technique. Okay, ni nanti I come back to this. This is some of other type of a mixer, right? And the rapid mix, normally the volume is about 8 meter cube. Then kita ada electric motor, gear type. So normally we will look at the radial flow or axial flow. Both can be used in rapid mix tank, how the effect of the flow. And the rapid mix, sometimes they have a buffer compartment into 2 compartment, buffer. So dia ada separate area. So kita kata sebagai at least 2 compartment and sufficient with the resident time of operation. So ada masa yang bersesuaian untuk pastikan bahawa ianya berlaku to form a bigger flock. And then vertical buffer, so we have this arrangement of the compartment so that it prevent the flow going up as a dia macam putaran vortex. So kita have to ensure that it's a vertical buffer. So we have the separation of in term of vertical line. Then kita selalunya ada impeller and a give tank for mixing. And untuk rapid mix, and we have this table to check our design so that whatever that according to the diameter of a tank, so we will check the tank diameter so that it will fit with the mixing the pedal with the tank. So ini antaranya kita kena perlu semak lah. Okay. So here is a radial flow turbine impeller. Dia berputar secara bulatan. So normally it cover onto a small area. And then kalau axial flow impeller, dia akan flow at up and down at the Y section. So dia akan lebih tinggi, putaran air itu lebih tinggi dan akan consume according from upper part to the lower part. As what you can see here, kalau axial ini yang berlaku, you can see the flow movement of the water from the lower part to the upper part on the Y axis direction, dia lebih tinggi. So kalau radial flow ni dia lebih concentrate and it has a smaller concentration on into the area. So kita nampak dia putaran dia lebih concentrate lebih kecil, dan yang ni adalah sebenarnya dia sesuai untuk rapid mix. Whereby the axial flow ni untuk slow mixing, when it comes to the slow mixing, sebab nak ada more contact with the other materials. Ini antara satu contohnya. So then of course the Foculation adalah process of the slow mixing. And then we have also G, the velocity gradient, and of course the time taken is much more longer as compared to rapid mix. And the G is according to the quality of water. So by looking at the turbidity, looking at how the percentage of softening. So it gives us the G. Then this is the selection of the G. And this you can see that the Foculation is suitable that we use an axial flow impeller or a pedal foculator, then or maybe buffer chamber, so they're the section. So axial flow impeller are recommended, and foculator basin normally is divided into at least 3 compartment. Okay. So itu adalah gambaran of how is the process, and I have this one example. Yang ni yang kita kata buffer. So this is the buffer, the separator to separate the compartment. So here we have ni kita ada 1, 2, kita ada 1, 1 sampai sini adalah 1, sini adalah 2 dan sini adalah 3. Kita ada 3 compartment in this tank. So ini kita namakan sebagai buffer chamber foculator sebab dia ada compartment, dia ada bilik-bilik. So the flow will go in and it will flow up and down in this compartment. Then power requirement for rapid mix and foculation, we will calculate the P as power and the impeller constant, small n, and also the D, impeller diameter. So we will check, right? So here, by looking into this, sometimes you also have to calculate into the drag force. Drag force is about ada geseran antara pedals dengan pengacau itu. Pedals ni adalah pengacau dan air ni kita mengambil kira drag force. So drag of the pedal. So we will calculate the P because of the drag force ini. Right. Okay. This is one example on this. Okay. So yang ni hari ni overview saja. So I will come back with this exercise and you can also look through the exercise. Okay. Proses ini example 6.11. If you read this question, dia adalah proses foculation dan juga proses yang kita hanya lihat kepada rapid mix and also the slow mixing. So coagulation tak ada, jadi sebenarnya kita fokus kepada foculation process dan juga rapid mix. Okay, so that's why you can see lagi section dekat bawah tu is dia calculate rapid mix dan also foculator basin. Okay, dia cakap dekat sini normally this is the question that we used to give to all of the student. We ask you to design because sometimes the city is they have to install a new water treatment plant because the population is start growing, so they need a new treatment plant. So currently they have this one rapid mix basin, right? And then the flow is split into two foculated train. That's what they want in their new water treatment plant. Ada satu rapid mix basin and then the flow will be for foculator basin tu dia akan menerima dua flow daripada rapid mix basin ini tadi. So from here, ni ayat dia ni dia kata they need a rapid mix basin, and then from rapid mix it will flow into two train. So akan ada dua aliran yang di mana ianya akan dibuat sebagai, ini kita panggil train, train foculator train. Di sini adalah foculator train. They have two foculator train and each of the train ni akan ada 3 equal basin. Okay, this is how roughly it looks like. So from the rapid mix basin, so it will flow out into two train, and then from each of the train ni, you will have 3 equal basin, 3 equal volume basin, and the water depth for all the basins is 4 meter, and determine the correct basin volume, the basin dimension, the tank equivalent diameter, and the power input, impeller diameter, and also the rotational speed for the following parameters. So everything is given, and of course you can see the rapid mix, the time given is much more smaller, dia 2 minutes sekejap saja. Tapi untuk foculation process dia akan ambil masa yang lebih lama. Okay, so ni foculation ni dia lebih lama lah, dia memerlukan 30 minit. Kalau rapid mix is 20 minit. So by looking at this given parameters, kita dah nampak, so we need to design one basin for rapid mix and the other basin for foculation ataupun foculator. Right? Then of course they will give you the diameter for the radial impeller type and also the axial impeller type. So they have the selection of the diameters. Then we need to check those for all the diameters, which one is suitable. Nanti kita tengok dia punya range, allowable range, and also given the power number. Because we need to calculate given the power number. So nampak solution dekat sini, of course ni nampak dia memang nak cari rapid mix basin. So you start with the rapid mix design. Okay, you can look through this exercise, tengok, and this is the good way of how you're going to solve for any problems, any question for the test or assignment. This is the step that you have to follow. Maksudnya buatlah secara slowly, but and then it's clear. So kalau you tersalah kira, tersalah tertekan calculator dan sebagainya, tapi when I look at the method, I nampak betul, but still you can get marks. Bukan sikit, banyak juga sebab method betul. So we by looking at the calculation, kita nampak you faham. So maybe because the error of the during calculation tu tadi. So you still get a lot of marks of the method. So kalau you follow through this example, if you can do it macam example ni, you are half memang dalam tangan lah, markah tu dalam tangan. So lagi sikit tu kalau jawapan betul, you get more, right? So that's my advice to you. So you nampak how to calculate the volume, So given the rate, flow rate and detention time, then you calculate the area, and of course you check because they have the same equal size. That's why you have two equivalent length, 2 meter for length and 2 meter for width. Dan kita check juga the equivalent on the T, kita panggil geometric ratios of the impeller, so that bila kita dianya berputar is still in the range of 2 meter. Okay, I will explain nanti. Then they calculate the P, right? We calculate the P looking at the power. And then of course from the given, kalau untuk rapid mix, ianya sesuai untuk radial impeller diameter. That's why we choose radial for rapid mix. And then we check the diameter as what given on the equation. Kita check 0.8 meter, 1.1 meter, 1.4 meter. Kita check the diameter and we will provide the according to the range. Kita kira dan this will be the allowable range, dan kita nampak 1.1 radial impeller diameter size ni yang paling sesuai as compared to the others. Okay, this one very fast. I try to give it very fast so that you akan ambil dan melihat balik lah. You akan do it as a homework. Look through this example, then I will give dalam WhatsApp example on the jar test also. Then after you are done with this, you will check on the end, rotational speed. So the speed on the rotation, by given a power. And then B, section B, you will study on the Foculation design. So Foculation design ni yang slow mixing. Slow mixing. Nanti next class saya nak tanya apa beza coagulation process dan juga Foculation process. So this is a slow in term of mixing, dia lebih slow. Of course dia punya time tu lebih lama taken, it's about 30 minutes. Then kita dah tahu air yang keluar daripada first process tu akan dialihkan kepada 2 train, and each of the train will have 3 basin equal volume. So kita ada 3 basin, each of the line tu ada 3 basin, right? So then you can see the calculation here is divided by 3, okay? And then so it's the same method that we solve, and we will find the equivalent tank diameter basin, right? So this is with the power, the creation of the power. Dan juga they will be the axial impeller diameter. We will look into this calculation. Tengok yang paling sesuai. And then from here we choose 1.4 meter, right? Okay. So from here kita nampak so what will be the end, again the rotation speed, and also at the end tu kita akan mengira di hujung tu the tip speed, di hujung pedal itu. So this is how it will looks like. So each of the compartment, kita ada 3 compartment di sini. This is the chamber, ataupun kita ada 3 chamber tu tadi, 3 basin on the Foculation basin, and then we have the buffer. So we have 1, 2 dan 3 chamber lah, 3 compartment. Okay. So then we have a pedal here, and then kat ujung ni kita mengira dia punya speed lah. So the movement of the water due to the pedal mixing. Okay, then kita dah masuk proses sedimentation. So what I'm going to do next class, when we come to 2 hours class, so kita akan repeat balik what we have learned today. Then kita akan repeat balik dan kita akan tengok soalan ini, example ini again. And if you kalau esok dan hari weekend ini, when you look at this example, cuba tengok example ni. So kalau ada soalan, kita akan juga berbincang pada next class. Nanti kita jumpa pada kelas yang 2 jam itu. So as I will leave you with this example. Cuba tengok example ni, cuba fahamkan dulu the flow, cuba fahamkan dulu what is the rapid mix and what is Foculation process. So fahamkan dua benda ni. So I will come back and explain, dan juga we will do it again, example 6.11. Tapi it's better that you go through dulu so that you will know what to ask. Ada apa-apa soalan lagi? So, ada apa-apa soalan? Attendance jangan lupa. It's very important for the attendance. Ada apa-apa soalan? Anis? Kalau tak ada soalan, we will continue with next week class, yang 2 hours class itu. Okay, kalau ada soalan, you boleh tanya. So insyaAllah I'm around. Dan juga you can wait for class, next week class. Okay, so selamat buka puasa. Right, so okay, so I'll leave you with this example. Is it okay atau nak teruskan sampai pukul 6?
Okay, Dim.
Okay, so have a good buka puasa. So selamat, take care everyone. So Assalamualaikum.
Waalaikumsalam.
Thank you, Doktor.
Salam.
Thank you, Doktor.
Bye.
Thank you, Doktor.
Selamat puasa.
Thank you, Doktor.